So now let's move on for the next problem, which is the conduction through a hollow sphere. So in this kind of problem, we will also be dealing with conduction, but instead of conducting through a cylinder, which we were able to solve before, ngayon naman is through a hollow sphere. Now, I want you to read the problem first and understand what's the concept behind it, and then after that, you can go back here and then we'll just start solving this. And by the way, the figure is already given, so this is something like a imagine a plane is divides that sphere. So ito yung makikita nyo sa loob niya. There is this R sub 1, which is the inside, the radius from the center to the inner diameter, and then R2 is from the center to the outer radius of that certain sphere. Okay. So I hope na basa nyo na yung mga tungkol dito sa ating problem. So let's just analyze the problem first, no? So remember our formula for our heat of conduction through certain geometrical shape in a steady state condition is negative k dt over dx. And before, we have derived this kind of the formula for finding the heat rate through a hollow sphere, and this is given by Q is equal to 4 pi, and then we have the thermal conductivity, then the difference in temperature, then we have here the negative symbol, and then this is simply the reciprocal of the area, which is this one is R1 and this one is R2. So this is a pretty easy equation to memorize now. So if we're going to solve for example, the heat rate, the surrounding temperature for the heat rate, so what we need to do here is to find the value of our T2. So we need, in that case, Q, and then yung K natin, of course, R1 and R2. So this R1 and R2, we can obtain that from a given here na sinabi sa atin, the outside surface area of the sphere is 314.1593 square meters. So with that, we can use the area of the sphere to find the value of our R. In that case, we will be able to solve R2 and then use some thickness to get R1. So we've got no problem with those values here. But the only problem here is that we need a certain value of K. We know very well that our spherical tank is a platinum. It's made up of platinum. But in this case, the problem didn't specify what is our thermal conductivity. So your first analysis would be, okay, I need to find the other temperature so that I can interpolate and probably find it on our Paris Handbook. But sad to say, there is actually no given temperature here, because if you have read the problem, what is given is the saturated steam pressure, and there's nothing else. Okay? Because technically, we need to find the thermal conductivity first before finding the temperature. But remember, thermal conductivity is dependent on our temperature. So how do we solve such kind of complicated problem? So with that, let us first enumerate the given here para mas madali tayo mag-solve, no? So let's start with the radius, yung kitang-kita natin, no? So to start with that, we need to find the radius first of the sphere. So we are given by the area or the outside area, which is equal to 314.1593. So remember, our area for sphere is given by 4 pi r squared. And in this case, since this is the outer area, this should be r sub 2. So you just calculate it and we will be able to find our r sub 2, which is equal to approximately 5 meters. So with that, our R2 now is 5 meters. And then, if you wanted to continue solving for R sub 1, then it can be solved by simply subtracting the thickness from R sub 2. Kasi kung makikita nyo naman, this is R sub 2. So, if you would subtract the thickness, which is given here as 15 centimeter, then you'll get R sub 1. So, that is 5 meters. And then minus, that is 15 centimeters. So, we need to divide this by 100. So, we get the same unit. So, therefore, R sub 1 is equal to, so that will be 5 minus 0.15. Our R sub 1 is 4.85 meters. So just to make it clear, our hollow sphere is made up of platinum, in which the inside the radius is 4.85 with a thickness of 15 centimeter. That's why the outer radius is 5 meters. So we're done with this given. Now let's try to take a look on our heat rate. So the heat rate is given by 17 megawatts. So it is in megawatts, so 17 megawatts is actually equal to 17 times 10 to the 6 watts. So remember, mega is a prefix for 10 to the 6. So that is for our Q. 17 times 10 to the 6 watts or joule per second. Now with that, we're left with the unknown K, T2, and T1. So, in this problem, what's inside this tank is a saturated steam. So we need to find the temperature of that steam inside so that we can get the temperature of our T1, which is the lining or the inside radius of that sphere or the tank. So, how do we find the temperature given meron tayong saturated steam and then pressure? So we will be utilizing the thermodynamic property of our steam or water. So with that, we need to check on our Paris Handbook and then find what's the value of the saturated steam, the temperature of that saturated steam. Okay, so remember, so we need to check on the Paris Handbook and determine what is the temperature at, at 180 kilopascals. So at 180 kilopascals. So we need to check on the temperature at this condition, and this will be our temperature 1. Okay, so with that, let's check on our Paris Handbook. So what you will see here is the thermodynamic properties of water at table 2-305. So let's have some review first dito ng mabilis lang dito sa ating table or thermodynamic properties, no, because this might be new to you. So yung columns naman, I won't be digging much deeper kasi meron na tayong label dito, temperature, pressure, density. So yung units naman yan is K, megapascal, mole. So these are the units already, no. Now, kung mapansin nyo dito, this is the saturated property. So all the values below these label saturated properties are all the saturated properties. Okay, so we also have the saturated properties here, and then we have the single phase. Okay, and then the single phase properties are usually the superheated properties. Okay, so they exist as simply just one phase. And that is the same for all of these data here. Now, let's take a look on the values here and what does this mean, itong blank space na to dito, no? So all of these this data na una nyong makikita, these are for the liquid, saturated properties of liquid water. And you can counter check it by checking on the density. Density in mole per decimeter cube is around 54 for water. So it makes sense na this is the saturated properties for liquid water. Now the difference from this table here na makikita nyo, separated by a single blank, yung mahabang blank na yan, is for the gases phase. So whenever we're evaluating properties of liquid and we know that, for example, ito ay steam, then we should consider the gas phase of that, or the vapor phase, which is this one. Okay? So remember, this is for the liquid and this is for the vapor phase or steam. Now, if you look closely, kung mapapansin nyo, the density is a lot smaller. Kasi kapag naka-vapor tayo, mas maliit ang density ng ating water. So, ayun. So, yun lang naman ang about dito sa thermodynamic properties of water. And we'll be using this a lot, especially when we go to convection. And for anything else, our first skill is my first goal is to introduce to you how we could find a temperature using this table. Now there exists an equation which is known as the Antoine equation. Actually, you can use it, but to be more precise and to be more familiar with our Paris Handbook, let's just use this table, and we will be interpolating with that. Now, in this case, we have a pressure that is in megapascal. It says here that in the problem that the saturated steam is at 180 kilopascal. So if you want to convert this 180 kilopascal into megapascal, since yun yung kailangan nating unit, so we just need to divide this by 1000. So our answer for this one would be 0.18 megapascal. And now that we have the value of our pressure, now we can just check here kung saan ba papatak yung 0.18 megapascal. So with that, yung 0.18 megapascal is around dito sa pagitan nitong dalawa. 0.17964 and then we have 0.24577. So with that, you would be expecting that your temperature would lie somewhere between 390 and 400. And actually, the answer should be close enough to 390. Mataas lang ng konti. Kasi nga, yung 0.18 is sobrang lapit dito sa 0.17964. But just to make sure that the calculations are correct and accurate, we will be interpolating still dito sa 0.18 Now, what if something happened and then nagkamali ka ng ginawa? Nag-check ka dito sa liquid phase, okay, sa liquid water. Actually, you will also get the same answer. You should be getting the same answer. Because these are the saturated properties of our liquid. So, whichever the condition of water is, for example, liquid char or steam, you should be able to get the same saturated property for that case. Kasi nga, saturated so, for example, at that certain temperature, yung maximum amount of vapor phase liquid and then the liquid na water is dissolved in that system. So, sabihin natin na parang nag-equilibrium sila dun sa certain pressure and temperature na yon. Okay? So, that's the same. But, you need to always remember na dapat ang gagamitin mo is itong portion na to kasi what if we need something like enthalpy or entropy? So, it will be a lot different. So, don't forget about it. Para maging sanay na kayo, always use the same part of the table. Okay. So, now let us just try to interpolate between these two values from 390 to 400. So, for 390, we have 0.17964 and then for 400, we have 0.24577. So, I will not be linking another calculator na dito kasi alam ko naman marunong na kayo mag-interpolate, So, if you're new to this problem or hindi nyo nakita yung previous problem, then check on the first problem yata yun. So, I'll be linking it naman para makita nyo kung paano nag-i-interpolate ng mabilis. Okay? But, yun nga, I hope you already know how to do it. So, let's go back to the problem and based dito sa interpolation ko using 0.18 megapascal, so, ang sagot based on 0.18 megapascal, the temperature is 390.0544. So, remember, you can also use the Antoine's equation. So, kung tandaan nyo siya, yung napag-aralan natin sa stoichiometry or sa calculations, yung 7 log Vp equal to 7.9668 minus 1228 over 25 plus the temperature, plus 228 plus the temperature in degrees Celsius. So, Additional info lang yun. So, hindi ko na siya isusulat. Check nyo na lang yun sa mga, previous notes. So, pwede yun. But yun nga, para masanay kayo sa Paris Handbook, so let's just use this. By the way, this is in Kelvin. So, there we have it, our T1. So, if you're asking or if you're confused bakit naging T1 siya, no? So, sometimes we also have to understand the problem na this is saturated steam at 180 kilopascal. So, when we talk about steam, alam natin na medyo mataas yung temperature niyan. And then, nasa loob siya ng tangke. So, by yung practical setting natin, malalaman naman natin na technically, mainit yung nasa loob. And then, yung sa labas natin na surrounding temperature, mas malamig yun, no? So, I don't have to mag-isip kung paano ba yun nakuha. Kasi, by, yung tama naman na by natural instinct natin na, syempre, kung sobrang init na nasa loob, malamang yung labas, yun na yung malamig na portion, no? So, sabi nga natin, kung ano yung mas mainit, yun yung magiging T1 natin. Okay? So, we're pretty much done with the given, no? Given pa lang naman yung hinahanap natin. So, meron na kasi tayong Q, and then meron na rin tayong T1, meron na tayong R1, and then R2. So, we just need to find our K and T2. So, yung K and T2 natin is, para silang wala. And remember, K is dependent with T2. So, if for example, our T2 is already given, then, syempre, hindi ito yung tanong. Iba na yan. But the thing is, if T2 is already given, then we can determine K by simply looking at the table, no? Pero with that, let's try to look at the table para ma-check natin kung what is the difference of having no T2 and then we need to find that certain K, no? So, this is the thermal conductivity temperature table for metals. So, under lang din ito ng mga nakita natin before na thermal conductivity. So, ito yung nasa table 2-327. So, at 9th edition, I will just be writing it on the probably description or anywhere. Makikita nyo naman yan. So, with that, let's take a look on our platinum here. And this is the metals. So, platinum is this one. Okay? So, if you have a Paris Handbook, you might as well want to create something like acetate film. So, para meron kayong ganito kasi mangyayari. Pag may acetate film kayo and then meron siyang print, so, ganyan yung makikita nyo. Mas madali siya, no? Instead of using ruler. So, sometime I will be, gagawa ko ng video para makita nyo kung paano gumagamit ng gano'n. Pero, it's not a priority, so, wag muna yan. So, with that, let's try to take a look at this one. No? Platinum is, yun nga, at low temperature, mataas siya. Kasi nga, these are metals, good conductors, no? Pero kung mapapansin natin, around 200, 300, and 400, up until dito sa 1,000, no? Medyo nag-stabilize siya to 79 to 78. Parang dun lang naglalaro yung ating thermal conductivity. So, the question is, ano ba yung gagamitin mo dyan? So, for example nga, na nakita natin yung ating T1 is 390, so you might as well want to think na baka 400 or 72, no? So, kung mali naman ako, malapit lang naman, no? So, that is true, no? Totoo naman na tama naman yon na malapit siya. But we need to make sure na tama yung ating assumption for that, no? And the best assumption that we can do there is that if this one is the surrounding or the outside surface, so i-assume natin lagi na nasa surrounding yun, no? Naka-expose siya sa environment. So, what do you think is the temperature outside? So, di ba, usually mga 25, 28, 29. So, around doon yung mga temperature na yun. And when we convert those temperatures into Kelvin, let's say mga 25, di ba, it is around 298.15 or to something like that, no? So, we could just simply take this 200 and 300 para magkaroon tayo ng idea, at least, kung ano ba talaga yung ating K. So, with that, we need to find an equation that relates these 200 and 300 dun sa K and then our temperature. So, that is an easy way, no? Kasi, you already know the interpolation. So, using your calculator, di ba, meron dun sa stat, and then meron dyan na A plus BX. So, this only means na ang magiging equation mo is y equals A plus BX. And then yung B mo is the slope, and then X is the independent variable. In this case, Y becomes our thermal conductivity, which is K, and it is a function of our temperature. So we have there A plus B T. So this will be your working equation for our thermal conductivity. So with that, let's try to write the equations, write the data in our statistics table. So, okay. So 275 and then 373. So I hope gagawin nyo rin siya para magkasabay tayo, no? 200, 300, and then 75, 73. So, kung correct yung nagawa nyo, you should be able to find the values of A, which is equal to 79, and then B, which is equal to, let me check, negative 0.02. So, dapat ito yung makukuha yung values, no? So, ang i-input lang natin na values sa X and Y is yung nandun sa Paris Handbook. Okay? So, in this case, our K as a function of T is simply 79 minus 0.02 T. So, that's simply our working equation for our thermal conductivity. And, can we just plug in this value doon para tapos na tayo, no? But, hindi yun pwede. So, remember, yung one of our problems in slabs, kapag given yung ating thermal conductivity as a function of temperature, we need to derive it from our original equation or the Fourier equation, no? So, hindi naman ganun kahirap mag-derive sa ating sphere. So, we just need to derive it again and then makikita natin kung ano ba yun. Kasi, ang difference kasi is that this is just T. Ano ba yung tinutukoy dito na T? So, yun nga, kaya T lang to kasi dependent siya sa temperature gradient ng buong yun. So, with that, we need to rederive this using the Fourier equation. And so, let's just make a quick derivation. No? So, Q over A is equal to negative K dt over dx. And remember, the area of a sphere is 4 pi r squared. And then, this is equal to negative K dt over dx. So, we separate the this should be dr. So, we separate the variables, so we get dr and then 4 pi r squared. This is equal to negative. Now, k would be negative 79 minus 0.02 t, and then we have here dt. Okay? So, with that, our integrate natin to from r sub 1 to r sub 2. Mangyari ito is, di ba, this can be rewritten as q over 4 pi multiplied by the integral of r raised to negative 2 dr. This is from r1 to r sub 2. And then this is equal to negative the integral from t1 to t2. Then 79 minus 0.02 t dt. Okay? So with that, let's continue. So, our q over 4 pi, this one should be negative 1 plus 1 all over negative 1. So, we have here negative over 1, and then this one is r, evaluated from r sub 1 to r sub 2, and this becomes negative 79t. This becomes plus 0.02 power rule t squared over 2 evaluated from t1 to t2. So, we continue doing this. So, q over 4 pi. So, we get 1 over r sub 2 minus 1. Oh, sorry. Napabilis sulat ko. So, minus 1 over r sub 1. That is equal to negative 79 t sub 2. Then, plus 0.002 t sub 2 squared over 2, and then minus. So, that is minus negative 79 t sub 1, and then this one. So, if we would subtract this to the negative, then we have positive 79 t sub 1, and then this becomes negative 0.02 t sub 1 squared over 2. So, this is our final equation. Now, we need to substitute all the values that we have obtained before. So, I hope tandaan nyo pa yung mga values natin. No? So we will be substituting all these values na. So, what do we have here is Q, which is 17 times 10 to the 6. So, I change the color of my... Okay, so we have here 17 times 10 to the 6. Then we have here 4 pi. And then, remember, we also have a negative here. I forgot to write it. So, if we have a negative sign there, then mabaliktad to pag na-distribute. So, we have here 1 over r sub 1. And remember, r sub 1 is 4.85 meters. And then we have minus 1 over, so remember, this is 5 meters. So, that is equal to negative 79. And our T2 is the one that we're looking for. Okay? And then, plus, we have there, plus 0.02 t sub 2 squared over 2, or you can just simply write this as 0.01, and then plus 79. Our 79 here, our T1 here is, remember, that is 390.0544. So we get 0544. I'm sorry. I'll just rewrite it para kita nyo. Okay? And then, we continue minus 0.02 and then 390.0544 squared over 2. And then, let's just use our calculator to find our T2. So, with that, I want you to calculate kasabay ko, no? So, medyo magiging matagal to, so bear with me. Okay. So, with that, my answer is 274.4039 Kelvin. Okay? So, we have already gotten the correct answer, and paano ba natin malalaman kung tama ba itong sagot natin, no? So, technically, it should be correct when your answer is, if your answer is, if T2, if T2 is, greater than 200 but less than 300. So, why is that case? Ba't ko sinabi tama if ganun yung sagot? Kasi, remember, in your Paris Handbook, dito natin kinuha sa values na to yung ating data, 200 and then 300. So, if ever na tama yung nakuha natin with regards to those values, then it should be correct, no? Okay, so it should be correct. And then, the next question is, what is our thermal conductivity? So with that, you could just simply use the equation. Where's that equation? So, you could just simply use our equation here. Wait, let me see. Yeah, this one. Okay? To find our K at T2. So, di ba pag sinubstitute natin itong T2 dito, then we have yung ating K at that temperature. So, we also have naman yung ating K at 390 using this, this equation. So, with that, let's just use this equation para makuha natin yung ating K. So, K is equal to 79 minus 0.02, and then we have 274.4039. So, our K at this temperature is equal to 73. 120. So that is in watt per meter Kelvin. Okay? So yun yung ating K at 274.4039. Pero since we need this thermal conductivity na average, so we get our K is equal to the average nito, and then yung isa pa nating thermal conductivity, which is dun sa temperature na 390. And remember, 390 here, kung matatandaan nyo, is not actually, hindi siya pasok dito sa ating temperature gradient na 200 to 300. And if we will be using this function, for example, try natin na hanapin natin yung K at 390.0544. So that is equal to, so I'll just be using my calculator to solve for this one, and the answer would be equal to 71.1989 watt per meter Kelvin. So with that, let's compare it kung halimbawa ginamit natin itong 390 and 400. So mapapansin nyo naman, yung 390 is around malapit sa 400, and it is almost 72 naman, no? So it is quite close na rin kahit pa hindi natin siya gamitin. So I think it will still be okay na yun na yung gamitin natin. Since ginawa natin kasi is nilinearize natin yung equation, so mag-stick na lang tayo dun sa ating assumption na yan, no? And by the way, the discrepancy naman is napakaliit. So with that, let's just take the average. So we have 73.5120 plus we have 71.1989. So we have 71.1989. 71.1989, and then okay. So with that, our answer would be equal to 72.3555. Okay, so watt per Kelvin. Okay, so given that thermal conductivity, dapat, if we wanted to check this answer, dapat yung makakalculate natin na Q here, using this T2 and then this K should be equal to 17 megawatts, or it could be, syempre, due to some, mga rounding off natin or some assumptions, medyo baka magkaroon discrepancy, but hindi naman siya sobrang laki. Okay? So, ayun, yun yung atin for our cases na meron tayong hollow sphere, pero yung ating hollow sphere is medyo nagkaroon tayo ng quite complicated case kasi nga yung ating K is, yung ating outside temperature ay hindi siya given, and as well as yung ating table, dun pa tayo magge-generate ng ating sagot. I mean, dun pa tayo magge-generate ng mga data equation for our thermal conductivity. So, yun, I hope you've understood this kind of problem. Medyo, lang siya naman. Medyo, nagkaroon lang ng konting complicated solving, no? And kasi medyo marami tayong tables na ginamit. So, anyway, if you wanted to check, I've got the answer for Q, which is equal to 17 megawatts, and then 8. So 17,000. Need to be careful with the number of zeros. So ito yung nakuha ko. So ito lang naman, 8 watts lang naman yung napadagdag natin dun sa 17 megawatts. So napakaliit naman nun nung difference na yun dun sa ating Q. So that's it. Tama yung ating sagot. Okay? So I hope you've understood this lesson, no? So yun lang, and then from this discussion onwards, we'll be combining a lot of resistances. So I'll be discussing about conduction through slabs, in which there's a series or parallel Kasi kasi nga sinabi natin before na ito yung resistance eh. So with that, kung ito yung resistance, kailangan talaga meron niyang mga series. Kasi imagine, remember dun sa ating hollow cylinder, papayag ba kayo na yung ating heat losses ganun kalaki? Diba our only goal is to eliminate all the heat losses or probably minimize it, no? Kaya naglalagay tayo ng insulation sa kada pipes. So, yun talaga yung main goal ng engineering or especially chemical engineering. So, alamin natin kung ano bang insulation yung pwede doon para ma-prevent natin yung heat losses. Okay? So, with that, we will employ series of conduction.